Example 1.9 is going to present us with our first example of a infinite map. And this one's particularly interesting because whenever you look at your definition, I can see here I have my first set, which is represented as the set of natural numbers, and my second set is the set that contains 0 and 1. So my first set is infinite, but my second set is finite. So you can see that there are lots of different possibilities for making maps. So I want to try to do some kind of arrow mapping, even though it doesn't say here in the directions to do an arrow mapping. It just says graph F on a Cartesian coordinate plane. But I think the arrow mapping might help us to get an idea of what's really going to be taking place. So for the natural numbers, because the natural number set is infinite, it's not going to be possible for me to list all of them. So I'm just going to list an excerpt of them. I'll say 1, 2, 3, 4, 5, and then I'll just put a dot, dot, dot to indicate that this is supposed to be a infinite set. And the second set is finite. It's just 0 and 1. So the mapping definition goes all the way from here over to here. What you will notice with this infinite map is that because there is an infinite number of ordered pair that we can create, it's not going to be possible to list out all of the ordered pair like we did on the previous examples. So we have this equation that tells us how to be able to make the mapping be fulfilled. This is known as a piecewise equation. And here's what this piecewise equation says. It says that if your number is even, then it is going to map to 0. If your number is odd, then it needs to map to 1. So looking at my set of natural numbers, if I start with the number 1, I should recognize that that's an odd number, and according to my piecewise equation, if it's odd, it should map to 1. So 1 will map to 1. Second natural number is 2, which is an even number, which means 2 needs to map to 0. 3, another odd number, will map to 1. 4 is an even number, needs to map to 0. 5, odd, will need to map to 1. So there's a bit of a pattern here, and that's a lot of what mathematicians are interested in doing, is just being able to describe a pattern. So we can plot these points. We would have 1, 1, 2, 0, 3, 1, 4, 0, and 5, 1. Now what I would ask you to do when you're working with the Cartesian coordinate plane, I will provide you with the Cartesian coordinate plane to work with. I don't want to have you draw this every time whenever you're on a test. So what I ask you to do is fill the space as much as possible. So because there's this pattern going on, I can already tell you that 6 is going to map to 0. So I have another point that I can put on here at 6, 0. I will label this as F, and I should also go back and label my map as F as well.